Yeah, good morning, myself Krishna, and today we are going to make logistic regression algorithm. In my last video, I spoke about linear regression. In this video, we are going to focus on logistic regression algorithm. So this is one of the statistical method used for binary classification tasks. So when we talk about logistic, we are predicting binary outcome. So when you have to find out whether in one of the use case whether this is corona patient or whether this person is diabetes or not. If you get this sort of data where you have to predict success failure, yes, no, yeah, any binary notation like true, false, 0, 1, you can go with logistic regression. And this is widely used uh, algorithm in machine learning. So the function of logistic, it is generally sigmoid function. So just to draw here, in my previous video, what we have seen, we mostly talk about this linear, but now we are going to talk about sigmoid function, which value always fall in between 0 and 1. So if you, whatever data set you will get, if you start drawing the line, you can see uh, it is it is making sigmoid curve. So here, this is the formula for logistic regression. 1 um, divided by 1 plus e power minus z. Z is nothing but linear regression. Some people used to call M W. So W is equal to mx plus c. Uh, in my last video, I elaborated about this c and m. I mean how we can calculate those values. So this is how you can see the curve. It is between 0 to 1 sigmoid function. And in every algorithm, this gradient descent is required to find global minimum. So when you start drawing, you need to first find out the loss function in between all the points, and you can calculate cost function. So what happened? Just think we have started from here and we have 1,000 data point. So first you find out loss function for all the points and then take average uh, for uh, calculating cost function. And this is how the final formula for the loss function, cost function. Yeah, this is very important. So this is actual value, predicted value, and this is how you have to calculate. So if you are writing logistic regression, this is how this formula you need to calculate, formula you need to use for calculation. First, pros and cons we can talk. This is simple, easy to understand. This can be scalable to large data set after efficient training, less prone to overfitting for low dimension data, perform well on data with linear relation. And cons could be high dimension data cause overfitting, sensitive to outlier, need a large data set only for binary outcome. Okay, so we can switch here. So first, let me comment and go one by one how things are working. So just see, this is my data, diabetes patient. So in my data set, we are trying to find whether patient is diabetic or not. So we we have a number of features and column. One of the column is outcome, and this outcome is the result where it says this patient is diabetic, yeah, this patient is not diabetic. If you can print here, uh, uh, just data, your value you can print, not everything. And you can print this feature target, that also fine. I'm just printing few data. So here you can see the data. We have at last we have the outcome, and these are the feature. So when we have this measurement, we can say this is diabetic patient. When we have this measurement, we can say this is non-diabetic patient. And what we need to do, we need to this is my entire data set. We need to, like I said in my last video, first, whenever you get the data set, you need to uh, split into the feature and target. So this is X feature and this is should be Y. Outcome is target. So this is what we are going to do next. And we need to standardize data generally when we get the data. Like one of the concept I shared, data imputation, where you are trying to removing uh, blank data. Similarly, it's better to standardize data because maybe it happened in your feature data are in different measurements. So it's always better to standardize. That's why we have used this scalar concept here. So at this point, we have just used predefined library for data standardization. So feature is having all the columns. Here you can see I have dropped the outcome and target will have only outcome. And this is you can draw the, let me comment this one. We don't need this. So standardization, you can see this is how after standardization, you can see the data set like this. Now what we can do here. So now you can take again feature target after data standardization, and this page is for splitting data into the train and test. So you are splitting data into train and test. So test side should be 20% and your training side should be 80%. So 80% we are taking for training, 20% for test side. This value you always keep 2 or 3. If you want to pick same type of data in your next iteration. So once we get X, Y, you can print it. And this point, we can use logistic regression. We can use direct model, which can calculate by our predefined library. But I have written one small code for logistic regression. It is doing same thing, whatever our library is doing. So if you want to use, better to use the library one. So once we get here, this is how it will predict. Let me uncomment. X train prediction, X test prediction. So training test prediction. Just see how what it comes. Uh, didn't I print? I guess I didn't print this one. We can print here. Um, print the prediction for X trend and X test data. We can take this here. This is X trend. You can give new line and X test if you want. So you can say print the prediction for X trend and this is X test prediction. Prediction will be always your binary outcome. Now you can verify the accuracy. Let me uncomment. Show accuracy for test and training data. So you can see we have around more or less same accuracy for both 77. This is 76.6. Just think you instead of custom, if you want to use the model, generally people going with library predefined. So I'm using this model, right? Uh, and see what accuracy we are getting here. It is more or less same. I guess zero point 0.01 deviation you can see, but mostly this is 78, 76. And how you can, if you plot and see what it comes. So here you can see training data, actual versus prediction. I'm going to draw here. You can see blue and red. So So this is the draw. You can see actual training is in blue and prediction is this one in red. So it is fall in same way either 0, 1. So outcome is 0, 1. So if you see more or less, so it's fall on the same line for actual and prediction. So this is all for today's video. I am coming with some new algorithm in my next video. Thank you for listening. Bye bye.